So today we are going to look into a concept called ratio and proportion. So to go with the basics here, the ratio number 1 can be represented as x. Similarly, the second number can be represented as y. So the ratio between two numbers can be defined as x is to y. So we can also write this as x by y, where the numerator x is defined as an antecedent and the denominator y as an consequent. And the ratio has no unit at all. And similarly, proportion, if two ratios are equal, we can call them as proportion. Say for example, in general terms, if A is to B is first ratio and C is to D is the second ratio, provided if these two ratios are equal, we can call them as proportion. And in other words, it can also be said as A is to B proportionate to C is to D. So here you have find four terms in the proportion, where the first term A and the last term D are referred to as extremes. Similarly, the middle term, say B and C, is referred as means. So the formula for proportion is product of means is equal to product of extremes. In short, we can refer it as A into D is equal to B into C. This is the simple basic to define proportion. And to go with ratios, again we have many types of ratio. Among them, the first one is your duplicate ratio. Duplicate ratio can be defined as the compounded ratio of two equal ratios. See, duplicate ratio can be calculated in a simple way, just like it. If A is to B is a given ratio, duplicate ratio of A is to B can be defined as A by B into A by B, which is nothing but A square is to B square. So the duplicate ratio is nothing but the squares of the given ratio. Say for example, if A is to B, say 4 is to 6 is the given ratio, then the duplicate ratio can be 4 square, which is 16, and 6 square, that is 36. This is how the duplicate ratio is calculated. And triplicate ratio. Triplicate, again from the word it is very obvious that the triplicate ratio is nothing but the cubes of the given ratio. That is, A is to B is the given ratio. Let us take the same example. Say 4 is to 6 is the given ratio. So the triplicate ratio is 4 cube is to 6 cube. That is 4 cube, which is 4 16 into 4 64, and 6 cube, which is 126. So this is A is to B, that is given as 4 is to 6, and the duplicate ratio as A square is to B square, and the triplicate ratio is A cube is to B cube. Provided from this we can derive another types of ratio, that is, from duplicate ratio we can derive sub-duplicate ratio. Similarly, from triplicate ratio we can derive sub-triplicate ratio. So the sub-duplicate ratio of A is to B can be defined as square root A is to square root of B. See, here there is an example. If A is to B, that is 16 is to 25 is the given ratio, they'll ask you to find the sub-duplicate ratio of 16 is to 25, which is nothing but take the square root of 16 as well as square root of 25, which is equal to square root of 16 is 4 and square root of 25 is 5. So 4 is to 5 is the sub-duplicate ratio of 16 is to 25. And likewise, the sub-triplicate ratio can be derived from the triplicate ratio. So I already told you that triplicate ratio is the cubes of the given ratio. So in parallel, sub-triplicate is the cube root of the given ratio. That is, cube root of A is to cube root of B. That is what you are seeing in this point, in this slide. So example, if 512 is to 729 is the given ratio. So the sub-triplicate ratio is nothing but cube root of 512, which is 8, and cube root of 729, which is 9. That is 8 is to 9. And reciprocal ratio. Reciprocal ratio, again, it is very obvious from the given word that it is the reverse. So A is to B, you can say it is B is to A, simply ahead. So how it comes, like B is to A? See, A, the reciprocal of A is 1 by A, the reciprocal of B is 1 by B. Just by cross multiply these two terms, you get the reciprocal ratio of A is to B as B is to A. Is it simple? Okay. Next we proceed with the other type of ratios, which is again the common kind of ratio, which is an equivalent ratio. So what is an equivalent ratio? Equivalent ratio, again, A is to B is given if the ratio is multiplied or divided by the same quantity. That is a constant number. Say there exists a constant number called 2. If we multiply A by B by a constant number, whatever the resultant value is, they are the equivalent ratios. See, here the example is find two equivalent ratios of 4:5. So 4:5 can be written as 4 by 5. Here I take the constant number. I can take any constant number, but provided the same constant should be multiplied in the numerator as well as in the denominator. Say for example, if I take 2 as constant, I have to multiply 2 by the numerator, that is 4 into 2, and denominator 5 into 2. So the resultant value is 8 by 10, which is nothing but 8:10. Similarly, what is the other? Because since in the question they have asked you to find the two equivalent ratios, so I have derived only one thing. The second one is take any other constant number. So here I have took 3 as another constant number. So 4 by 5 into 3 by 3, because that is the same quantity should be multiplied both in the numerator as well as in the denominator. So the resultant value is 12 by 15. So 4:5 is the given ratio, and the two equivalent ratios are 8:10. Another one is 12:15. Next, comparing ratios. Another form. Comparing ratios. See, before you go for comparing two given ratios, they can give any type of ratios, any terms, but you have to find the common denominator. Simply you can't compare with the first term and the second term. First term in the first ratio and the first term in the second ratio. We cannot do such type of comparisons. So what I have to do is, if say in this example it will be very clear. Listen, if 3:4 is one ratio, which is written as 3 by 4, 4:5 it can be written as 4 by 5. So just try to find the that is the common factor, which is the LCM for the denominator. See, the first ratio the denominator is 4, and the second ratio the denominator is 5. So take 4 and 5, the LCM of 4 and 5 as 20. So make this 20 as common in both the ratios. That's what I have did here. So 3 by 4 to make 20, I have to multiply it by 5, and the second ratio to make the denominator as 20, I have to multiply these terms by 4. Isn't it? So now the denominator is common. Now you can straight away compare these two ratios with the numerator alone. So now see the first term as 15 by 20 and the second term as 16 by 20. Just look at the numerator, which is greater, 15 or 16? 16 is greater. So obviously 4 by 5, that is 4:5 is the greater one. So if they ask you to compare any two ratios, the first thing what you have to do is you have to find the LCM of the denominators. That is, you have to make the denominator as a common one, and then just check only with the numerator. Whichever the value is greater, you can say that particular ratio is greater. Clear? Okay. And a very simple problem. See, this is very easy or easier to solve. Find the ratio of 4:6. It is nothing but ratio of 4:6. You can write it as 4:6 or 4 by 6. In other words, it can be written as 4 by 6. Again, simplify it. If there is possibility to simplify, please go ahead with simplifying 4 by 6. I can again, there is a common factor 2, just by cancelling it by 2. 2 2s are 4, 2 3s are 6, so 2 by 3. So the ratio can be written as 2 by 3 or 2:3. This is the simple problem. See another model. They have given you a number or an amount, say in this figure. So divide rupees 2400 in the ratio 3:5. So 2400 is the amount given and the ratio is 3:5. We know the amount and also we know the ratios. We need to find, say for example, there is an amount. There are two persons who are going to share that amount, isn't it? So the total amount is given as 2400 rupees. Excuse and the ratio is 3:5. Now we have to find the share of the first person as well as the second person. So if the ratio is 3:5, first try to find the total parts. Total parts is nothing but 3 plus 5, which is 8. So the amount is divided into 8 parts. Am I right? So out of 8 part, 3 part is given to the first person and 5 part is given to the second person. This is the logic over here. So with this, we proceed with the problem. So the first part is 3, that is out of 8 parts, first 3 parts is given. That is why I have given here 3 by 8. Can you note this? This is 3 by 8 into the total amount. So this total amount, it is divided into 8 parts. Out of 8 parts, 3 part is given to the first person. So if we calculate this by cancelling it, we will get the answer as 900. This is how you can calculate the share of the first person. Similarly, the same flip rule here. The second part again, what is the second part ratio? 5. So out of 8 parts, 5 part is given to the second person. So it is 5 by 8 into total amount. So from the total amount we are dividing, isn't it? So you have to multiply it by the total amount. So while you cancel it, you will get the answer as 1500, which is the share given to the second person. Is this clear? See, you have an amount. That amount is divided among 2 persons. The amount is not given. That is, the individual shares of these 2 persons are not mentioned over there, but the ratio is given. So from the ratio, we need to derive the shares of the individual person. Yes, this is the second model in the ratio problem. Yeah, this is the third model. See, we can call this as a partnership problem too. So partnership, again, it gets mingled with the ratio and proportion concept. See here, I'll read out the problem. A sum of money was divided between Steve and Sam in the ratio 3:7. Steve got rupees 240. Then what did Sam get? See, in the previous problem, the total amount was there and the ratio was there. We have to find out the individual shares. Here the condition is reversed. The situation